Hi, everyone. Thanks for coming. Just a reminder to adhere to the Our Ladies Code of Conduct during this meeting. So no bullying or harassment and being fully inclusive and inviting to everyone. Uh, yeah, do we want to do organizer intros or? Okay. All right. Hi, I'm Melissa. Thank you again for coming. I'm one of the Our Ladies co-organizers. Um, Yeah. Oh, my flex is I went to the University of Auckland, which is where art was invented. So, I'll pass to Jasmine.
Yeah, I should just.
Do you want to just join?
Let's come here. Hello, I'm Jasmine. I am another co-organizer, and I've been with Our Ladies way too long. I stopped counting. Um, but yeah, if you are interested in making a talk or joining Our Ladies as a co-organizer, we'd love to have you. So yeah, you can contact us at Vancouver at ourladies.org if you're interested. And if you have any questions, put that in the chat and we will get Daniel's attention. Yeah,
Cool.
doing good.
Thanks. And then Daniel, do you want to introduce yourself?
Hello, I'm Daniel. I am a lecturer at the University of British Columbia, and it's nice to see some of my students here today in person and online. So thank you all for that. So one other thing before we start. The organizers have given me a whole bunch of these Our Lady stickers. So if you are a student, and you can hear my voice right now, you can find me tomorrow since we all have to be doing presentations, and I'll get you some stickers. All right, cool. All right. Ooh, I just need to find stuff. Give me 1 second. There we go. Sweet. All right, I can see the chat. I can see my slides, and we are good. All right, so I think we have like a very hard, we have to be out of this room by 7. I'm not going to be talking for 2 hours, so we'll be good. There are a lot of slides, but I don't think we need to talk through all of them. So I think we'll be pretty much okay. All right, so I am going to talk about the technical component of this little project that I did, which was how do we go and find the best cherry streets that have cherry blossoms in Vancouver? But we're going to do it instead of the general public way of talking about this. We'll talk about how you can actually do this in code and some of the problems I ran into, or at the very least, like the thought process I went through as I was going through something like this. And I guess for many of my students, I would say this is a really good example of how you can have a small data analytics project and you can still do a lot of really cool, meaningful work, and then the rest of it is essentially around science communication and how you can write stuff up, um, write things up, put it in a blog, write things up, putting it in a talk, and then giving it as a talk to an event like this are all different ways you can communicate things that are of interest to you. And again, I am not a botanist. I don't know anything about trees. And so, you can always start somewhere and learn as you go, and, you can teach people along the way as well. So the whole point, or not the whole point, but this pretty much started because we just are at the very end of the Vancouver Cherry Blossom Festival, which this year started end of March-ish, and it kind of just ended. And my actual motivation was literally my mom was coming to visit Vancouver at this time for the first time, and I knew that she missed the official Cherry Blossom Festival in David Lamb Park. So then the question was, if not David Lamb Park, where else would be worth visiting? Especially if you're scrolling through Instagram and you see the post around like, here it is, and you save it as a reel. I never will see that reel ever again, even if it's saved. So then it really became, it would be really nice to just have a map and just go to a map. Or if I'm walking around somewhere and just see, is there a street that's nearby? And that was sort of the whole motivation for all of this. I also run, so then it also became like, could I map enough points to do a little cherry blossom run, which maybe will be a plan for next year. So the goal was really, let's go find all the cherry blossom trees in Vancouver, find the neighborhoods, and then find the individual streets. And then again, this all actually came from a LinkedIn post by Kyle Walker, who, if you don't know who he is, he does a lot of the census packages around in R. And he also, right now on LinkedIn, he is, with the help of Claude, and he will admit this, he is making so many mapping packages in R and making it look really cool. So that's also why I picked R and not Python, for those who are asking, who want to ask why is this all done in R? It's because it actually is better, or at least it seemed better at the time. Everything you're seeing is coming from this repository. All the code examples are there, and this is the slide of like the thought process of all that. Okay, so if you're a student, I am trying to show you some best practices as I go. So there is a makefile in our repository, and it sort of runs through all the bits and pieces. It would be really interesting for someone to actually go and run this and see if it actually runs the way I expect on your local machine, but at least that's the actual plan. Like I said, Kyle Walker, literally, like I saw a blog post around, he shared one where he just created a package that does this traveling salesman problem, which I'll talk about at the very end. And I saw that. I was thinking about cherry blossoms, and then it became, how do we find the most common places with cherry blossoms, and then how do we walk through them was the initial goal. So Tidy Census, Tigris, MapGL, those are probably his most famous R packages, and almost any package in R that deals with maps is probably using something that he's touched. So I would say he is the map version of Hadley Wickham, is probably what I would say about that. All right, so this is a really technical talk. We're just going to very literally go through a lot of the analysis that I did. Some of the stuff doesn't show up well on slides, so I have some of my actual notebooks all queued up, and we'll just sort of talk about things on that end. All right, so a little thing about GIS. So the other thing about this talk is it also goes and ties into Grace's talk from last month around just creating Quarto websites and doing Quarto things, which is what sort of this presentation is, a Quarto presentation, but sort of where this whole analysis became super popular was it became a blog post that then I sort of like probed the media about like, hey, maybe this would be useful. And then it snowballed into a whole bunch of other like semi-viral moments. But again, it all stemmed from the fact that, hey, we were using Quarto, it was a blog post, it was hosted on GitHub pages, that entire tool chain is free. But again, then it's how well can you communicate a set of analyses that you've done. The other thing, and last year, the talk before Grace was actually a GIS talk as well. So it kind of is like, hey, we haven't had a bunch of talks in a while, so let's just do a GIS talk and then tie it into what Grace talked about last month as well. So really quick primer around GIS. It stands for Geographic Information System. Essentially, whatever, if you need to map something, that's all GIS. Two main forms of data that you work with. One is vector data, the other is raster data. Raster data is essentially just pixels and images. I haven't touched any of that stuff today. We'll be actually working with vector data, which there are three main points or three main pieces: points, lines, and polygons. And we'll see how all those get put together in this piece of analysis. Individual trees become points, streets are going to be lines, and then neighborhood are going to be drawn in polygons. When you actually work with SF data, or that's the package that we'll be using to do this data analysis, sometimes the data that you get are not just points, lines, and polygons. You'll have what's known as like multi-points, multi-lines, and multi-polygons, which is really saying, hey, you have a data set of points, it's just multiple points per row. Or not just individual lines, it's like multiple lines all put together. So you can think of it as like a list of those objects all get stored in one. So, and that's important because some of the geospatial functions that you do or try to run only operate on individual points, lines, and polygons. And there's a function that you can sort of explode that column up so it's not a multi-point, multi-line, multi-polygon. Right. So the other really important thing when you start working with GIS data is what's known as a CRS, or the Coordinate Reference System. This is essentially saying that the world is round, and there are things that are drawn or that exist in a round globe, but when we look at them, they're on a flat two-dimensional space, and we need some way to project a three-dimensional sphere down to a two-dimensional flat space. And there are many different ways where that transformation can be done. And so the CRS is one of the most important things anytime you work with geographic data, because you need to make sure that everything's on the same system. Otherwise, points are not going to line up, or points and lines and polygons. All of those features are not going to line up. And if they don't line up, you can't really do anything with your data. Sometimes they don't line up in a way where it's very obvious. Like, if you plot the wrong CRS for trees in Vancouver and all of a sudden all the points in Alberta, that's like a first place to check that something's wrong. But sometimes I haven't done GIS work enough, but a real danger is they're just off by a little bit where you don't notice it. And that could mean that things get binned in the wrong location and stuff like that. So it is really important that you pay attention to the CRS. And so even when you go and have a object loaded up, there is a stcrs function that you can put around any type of geospatial data frame, and it will spit you out the actual coordinate reference system that's in use. So there is a lot of ways for you to see what that CRS is, and also like transform given one or the other. So now the question is, okay, you have a CRS. Every time you look it up, you probably just see a bunch of letters and numbers. The most common ones are all pretty much related to one another. So EPSG 4326 is the same as WGS 84, which is essentially, when you are looking at Google Maps, that's what you're looking at. That's the projection system that Google Maps uses. Those are two different ways of writing the same thing. What you come back is the lat longs for individual points. And WGS 84, that's the version that I remember. You just have to know that there's another common name for it. But essentially, that's Google Maps. That's why you'll see, or that's why I remember WGS 84 anytime I look at maps. There's this other coordinate reference system that you'll see being used in this analysis, which is 32610, which is essentially saying that these points are on a round sphere of a globe. And this is saying that, hey, we're looking at this area that Vancouver is in. So anytime we do need to make distance calculations, it actually can account for like curvature of the earth and things like that. And so those are all going to play a really important role in any type of analysis that you do. But these are things that you typically check at the very beginning, and then you assume the rest of it is all operating in the way that you expect. But this is the most important thing you want to check for. And then the package we'll be using comes from a package called Simple Features. SF is the newer or the latest R package that does GIS work. If you've used R, I guess like 10 years ago, the package used to be called SP. So if you see SP code, just rewrite it to SF. It is much more tidyverse friendly and ggplot friendly. And that's also another reason why SF has been pretty popular now. I have yet to see R code using SP anymore, unless you're working with super legacy code. But here's a quick list of all of the functions that I've used. They essentially look like typical dplyr operations, but we are now doing them on geospatial objects. And you'll see some of that in play. This sort of presentation is actually, I tried to live execute all of the code. So like we are going to just have a bulk loading of a bunch of packages. You'll see that SF is being loaded. We are still working with data frames, so dplyr is still going to be being used. MapGL is a package that I only learned from Kyle. And that is using MapLibre, which is the free and open source version of Mapbox. So what ends up being used in industry a lot is this library called Mapbox. It costs money. You need an API key. There is a open source version port of Mapbox called MapLibre, and then that's what I've started to use, but I've only heard that from Kyle, and it's sort of like if Kyle says it's good, I'm just going to go and use it, and that's kind of how that works. All the other stuff were things that I tried to get Claude to prompt to help me do work on the traveling salesman problem. Kyle Walker, did I say Scott before? I meant Kyle. If I say Scott, that's totally by accident. But Kyle wrote this other package and this I don't know how to pronounce it. But this is the package that actually did the traveling salesman problem. And then I was essentially following his vignette and telling Claude to use vignette to get this stuff working. So I'm gonna go past that bit of the code, but I can still show you some of the results of what happened there. Yes, so a lot of my slides are gonna have like this empty thing, and that's because I have it set just as a default to please show the results of all of the R code on the following slide, but Cordo doesn't know that if a code chunk doesn't have output, it's still going to make another slide. So that's a little bug that I discovered 15 minutes ago before we actually had to present. And I was like, I'm not changing the slide deck. It's too late for that now. So that's where the empty slides are, slide pages are coming from. Okay, so first thing, where did the data come from? It comes from Vancouver's Open Data Portal. And we're going to be, it started off with the trees data set, which I think if you're an MDS student, you've seen this in a homework assignment before. But on top of that, it's a lot of the street data. And I only knew about these other street data because I realized when I was plotting the streets that there were a lot of streets that were missing. So it became look into the Open Data Portal and find all the other data sets that look like streets. And then the other data set that we use is the local area boundary, and this is the actual neighborhood data. So currently I'm talking in Mount Pleasant, whereas the box around Mount Pleasant, that's where that information is coming from. And again, there's probably stuff that I've missed. In this particular data portal, there's also a bunch of LiDAR data around elevation. So, you know, in theory, I could find optimized routes that reduce hills. So if you're trying to bike or run, and you just want a flat path, that could be like a follow-up thing that you could do that I have not incorporated. Okay, so most important package of the day is this library called SF for simple features. A lot of the SF functions begin with st underscore, so it follows the very tidyverse convention of namespacing functions in the actual function name. So instead of read CSV, we're using stread. I chose to download the data from the Open Data Portal as GeoJSON. That's just because it became a single file. The CRS is already encoded in that file. Everything is just in one thing. Other common and popular data formats would be ArcGIS's format, which is a shapefile, SHP file. Essentially, a shapefile is a really fancy zip file. One has the data frame. One is like just a file of the CRS, whatever it's using, and a bunch of other stuff, and like the polygons as well. Those are all separate files. They get essentially zipped up into one file, and that file is called a shapefile. I just didn't want to work with shapefiles because it's not plain text. And I've had some trauma in the past where shapefiles were incomplete, where like one of those files was missing and I didn't know why, and things went wrong. So GeoJSON, again, this also is really nice that the Vancouver government even has data in like all of these formats, or even has it at all, which not all of the governments around Vancouver have this type of data. So when you look at this particular data set, when you try to load it, it looks very much like a tidyverse or Tibble. The only special thing is you now have a column. That column name is called geometry, and all those points, lines, and polygons are stored in that particular column. So everything else, you can do normal dplyr things, and it will work. And then if you use any of these simple SF functions that do like joining, intersecting, and all of those, it by default will look for a column called geometry, and it assumes it is like the set of geometries it's looking for. So the word geometry or the column name geometry does play a really important role when you work with these data sets. There's other metadata information associated with it. So when you actually go and try to load this stuff, you get a lot of output that gets spit out. And again, one of the things that get dumped out is also the CRS that comes from this particular data set that you're loading. So again, you'll see WGS 84. I see it, and you essentially will confirm that they all say the same thing. And if they don't say the same thing, there's always a way to convert it. And if they say something that you're not used to seeing, you can always convert it. So again, that's how important the CRS is. It will pop up when you're even trying to load this data frame as just as like a normal message. Okay, so first thing, we're going to plot the trees data set. So it comes from the trees data set. One of the things that I very quickly realized that I didn't know was I initially looked for like cherry blossom. Like that's how much of trees I know about. It was like, hey, go find some cherry blossoms. And then I realized that, okay, there is more than one tree that has the word cherry in it. So there is a column called common name, and I am essentially looking for the word cherry. And then of the trees that have the word cherry, does it contain Jap or flower in it? So I'm either looking for things that look like Japanese flowering cherry. That's like one of the actual tree names. But that was the combination of trees that I'm looking for, which is to say that this could be an imperfect search of all of the trees. I believe there's like hundreds of different tree species. But this is the set that I found, and I kind of eyeballed it. So I could be missing trees, which is also like a big caveat with everything that I'm presenting. But if you do that search, you get 10 of these words that contain Jap flower cherry. And these are what I'm guessing is a cherry blossom in Vancouver. And so so this is the set of trees that I'm looking at. And this is the set of trees that I will be spending the next year trying to know how to identify by looking at them. But which is also really nice because one of the problems that you see people run into is they post a cherry blossom and it's really a plum blossom. So at least I know I'm not looking at plum blossoms in this data set, but I could also be missing cherry blossoms. That's also like the big caveat. Okay, so the other thing in this particular data set was they have data set around tree age, or really some trees are tagged with when the trees were planted. And one of my friends who actually worked for the city government, she told me that they usually plant these trees when they're about 2 years old. And so cherry blossoms typically start flowering around year 5. So the thought process was, oh, I have all these Japanese cherry blossoms. I don't want to just have like a skinny stick and just run to a whole row of skinny sticks, which I actually have ran into. So the thought process is maybe use the age. However, it does turn out that like almost 15,000 of the trees were missing. So and essentially like made that kind of a useless column because like 90% of the age data wasn't filled in. So we couldn't filter on that. The other, so if I tried to filter on like mature trees, like, yeah, there's like 72 of the trees were missing. So then I just said, okay, it doesn't matter what the age was. Let's just look at all of them. And that's just code output. The next thing that I tried to do, there was height and diameter measurements of the tree. I don't know when they were measured, but you could also say like, hey, if there was a tree that was around, I don't know, like 30 centimeters wide, maybe that is a mature enough tree that maybe it will be blooming. It also turns out that there wasn't, yeah, it turns out that even if I did a filter on this, there wasn't enough trees that met like a threshold to matter. So then the height, diameter, and age like didn't really need to be considered. And again, if I run into a certain block that were sort of young, then hopefully in the grand scheme of things, that's okay. Okay, so the next set of data comes from the public street or the street data. So what I ended up having to do, and this is something I had to find out later on, was It's not just the public streets. There's a whole other data set on non-city streets. I don't know what that means. But there's also lanes, like those little alleyways, because apparently trees get planted in alleyways as well. So this was my way of using the existing data just to find all of the streets. Looking back on it now, there's some benefits of looking at the data this way, and there's also benefits of looking at it not this way. The nice thing about this is all the streets come in multi-line segments, so they're all segmented out. The downside is and my friend told me, and this is why some of the auto mapping gets really weird, is there's potentially holes in this data set, even though they visually look like they're all connected. Under the hood, there's a hole. So sometimes when you try to do auto routing, it just routes you in like a really convoluted way because technically it doesn't see that that's a path. But this was my initial way of like thinking I had all the streets before I like realized that is a potential problem. But if you use the OpenStreetMap data, the problem then becomes you have to go and manually segment the blocks. And so that's, there's problems anywhere you look at it. So these are all the streets that I had. The streets also, they have different, you'll notice that they're sort of coded somewhat differently. So I also had to write some code just to make sure that the street label or like what the name of the street is all in the same column. So for example, street type, this wasn't always, like I was creating a new column called street label. I had to combine some other streets just so like there was an actual label on them. And the label was consistent after I combined all of the data sets together. So again, fairly common data joining problem of 3 different data sets, 3 different sets of column names. But this is one way you can combine them into one giant data set. Okay, so next, I have all the points data. I have all of the street data. Let's slowly start putting the map together. I have all the points data. This is using the MapGL, which is using MapLibre. And this is where I'm saying like, hey, I don't know anything about maps. Claude, please look at documentation and just start making maps for me. Which again, as long as I gave it my data frame, it sort of did a pretty good job just plotting what I needed to plot. So the why did that not show up? There we go. So the first thing is go and plot all the trees. So these are all of the cherry blossoms across Vancouver. And just looking at this sort of gave me some hope that like, yes, you can do some type of local clustering counts to get density. And that was the whole point. Originally, I didn't think about using street density at the time. I was thinking about just circles or some type of heat map, but just having this opens your way for all different ways of you trying to analyze this particular data set. The next thing, because I've done this before, and for my master's students, some of you actually have maps of Vancouver and you did the same thing was, hey, and I literally told you, hey, please like overlay the neighborhoods on top of this stuff so we have a general sense of like where things are. And so that's literally what I did was I took the neighborhoods data frame and we have, and then we added the polygon layer on top of that map. And so you'll see, well, you can kind of see that like there's these little polygons that have been drawn around all of these areas. And yes, you can add tooltips. So like if I hover over a box, like whatever, like Mount Pleasant will light up and stuff like that. But this is using the next layer in this GIS analysis of adding polygons on top of points. So now the question is, okay, I have these 2 things, and this is sort of what makes GIS like very powerful is you can have all of these different types of layers, and then you can have the layers interact with one another. And so what you can do is, did I put this? Oh, no, hold on. Let me take one step back. The other thing I did with my tree data was I have 10 unique different species of trees. And for whatever reason, I was just like, hey, how are they clustered around the city as well? So I have points over a polygon. I can now color the points based off the tree type. So here are 10 different colors of these trees. And one of the things you can do is like, hey, David Land Park is where the Cherry Blossom Festival is. And you'll see that like, oh, Davidland Park is literally all one type of tree, which is the Japanese flowering cherry, which is probably why they put it there. And then since we're really close to this section we're in the library, which is right here, 7th Avenue, if you didn't know, or I think it's too late now, but they're all cherry blossoms on 7th, except they're not flowering cherries. And I know they bloomed last week, so there might be some trees left, leaves left. So that was kind of like really cool to see. When I originally saw this, I was like, that's where I'm going to take my mom. That's it. Settled. Turns out it wasn't blooming yet when she got here, but that was the thing. But this sort of gave me some hope, because now you can clearly see like, hey, there's different types of trees, which I didn't really use, but they're also clustered around streets. And that was the next way of slowly thinking about what is the best way to find density. But that's still the problem I was still working with, of like, what was the best way to find density or clusters of trees? The easiest way, again, is using circles, but eventually I found like the street data. And then the other thing is like, now you can kind of like, if you found a post on Instagram and they said like, oh, like here's a region of where those photos are taken, you can actually go and confirm like, hey, that seems about right, and it's confirmed in a data set. So it would give me a little bit more confidence that maybe where these trees are plotted are actually trees that are being plotted. So that's just the raw data that's plotted on the points. The easiest question next was, I have neighborhood boundaries. Can we count the trees by neighborhood? And so this is where all of the GIS related functions can come into play. There is an ST join. So just like you're joining data sets on a column, you can join on like objects. And essentially this is saying each polygon is a shape, your points in a shape, count the points that exist in this particular shape. So you can sort of overlay those two things together. So what's really cool about that is then, yes, you can do those types of tasks and they're built into the SF package. Like you can think about intersecting and joins and overlaps or convex holes or whatever. That is all very common GIS functions that you don't need to implement. And again, Claude will help you a lot of the way if this is something that's very new to you. The other thing that I do just to make the data set smaller for plotting purposes was you can then drop the geometry column. And then what you're really left with is your normal tidyverse tibble, which you can do all of your normal tidyverse stuff with. So I joined everything. I have a count somewhere, and I'm literally then dropping NAs and then doing a group by aggregate count on my data set. Oh yeah, okay. The other thing that I ended up doing was I didn't really just care about counts in a neighborhood. You wanted to look at density. And so there is, again, a literal function called stArea. So given a geometry and assuming the coordinate reference system is all correct, it can calculate the area of that polygon. So the same thing you can do with lines. It can automatically calculate lengths. It can calculate area. So these are things you do not need to do by hand. As long as that thing exists, you can calculate or pull out those values. And so what I ended up doing was for each of those polygons or those neighborhoods, calculate the area. And then you are doing a density count, which is like count the trees in that area, in that particular area, and then divide it by the actual area to get a density count of your of the map. Okay, so back to actual mapping. The next thing that we can do is, instead of plotting the neighborhoods and the points on the neighborhoods, what you can then do is take the polygon of the neighborhood, and then what you're going to do is, what do I have it in here? Use the area or the density that I just calculated, use that as the fill color for that particular polygon. And then what you end up is a figure that looks like this. So darker means the density is higher, and then lighter means the density is lower. And then I clearly didn't add more data in this version of the slides. But here's Mount Pleasant. It is actually the densest tree neighborhood, But then if we look at here, this is downtown Vancouver where David Lamb Park is. It is like one of the least densest neighborhoods, which is like kind of interesting where you might say like, why is the Cherry Blossom Festival held in a region that has no cherry blossoms? Well, it's because all of them are in David Lamb Park. And downtown Vancouver is just very big and actually doesn't have that many trees. But where we are located, actually, if you just walk around during like cherry blossom time, it is the highest densest cherry blossom neighborhoods, which is actually kind of really cool. So yeah, Mount Pleasant has the highest density of the neighborhoods. David Lamb Park is one of the lowest, but the actual park is a very dense location. So then that goes back to my original problem of like, where do I go to take photos, or like, where would I go and visit? I have this paradox of, I know David Lamb Park should show up somewhere in my answer, but right now, if I just look at it through neighborhood density, it's not going to show up. So this is sort of like this thought process of you kind of know like some heuristic of what you expect, and the analysis you're doing isn't showing that. And that usually, hopefully, it means that like you're approaching the problem wrong, or there's something else that you've missed. And, you know, the scientific method of like, try something else, another way to look at this, which is different from like, hey, I have some thought process and I'm going to do whatever it takes to make sure that I confirm my own answer. That is not what I'm trying to do, but it is a little bit weird that like, if I just look at the map, that choropleth that I just showed you, there is almost no reason for me to ever go downtown. But then, and I've been to the Cherry Blossom Festival, like you should be there. So how do we deal with that problem? So then the problem became like, okay, so it's not neighborhood, because neighborhoods actually, it kind of makes sense. It's way too big of an area. So the next smaller unit that I can think of was hope that there was street data in the open data portal, which thank goodness there was, because the next step from there would be to like create artificial grids and almost create a heat map, and then use the heat map as a way to look at tree density. But luckily we had street data. And so then the question was the same thing was, okay, can I map trees to streets? And can I count how many blossoms per street? And then can I count how many blossoms per like street density? And Claude sort of gave me this idea of like, oh, you can sort of normalize it by trees per 100 meters. And so that's how I started the rest of the analysis. So then we can go into street level analysis. So here's the example, because this was something I really needed to confirm how some of these functions work, because now I'm starting to use functions I didn't even know existed, or methods that didn't know existed. Because the problem is the points data of the trees are not actually on top of the line data of the streets. Like they don't plant the trees in the middle of the street. They plant them on the sidewalk, or they're in a park, which is not even near a street. So you have this problem of like, how do I take a tree and map it to a street? Like that's problem number one. So there is a function. So what is this? Okay, so this is setting up an example. I have some fake streets, and I have fake points that resemble trees. So I'm using line data and point data. And there is this function called, where is it called? Actually, no. So this is what it looks like before all of that. So here's some example. Here are some example streets. They're lines, and here are a bunch of like example points that sort of represent trees. So my problem is like, what street should this tree be counted, or what street should this tree be counted on towards? And likewise for this one, or something like this. Like, does this go to this block or that block? I have no idea, and I don't want to hand do that. So luckily, there is a function called sfnearest feature, which I didn't know existed. So then I really had to ask Claude, like, can you come up with an example to prove to me that this function does what I think it does? And this is where this little toy example came from. And then I sort of really adapted that example to make sure that I understood what was going on. And then that gave me confidence that I can use this on a larger scale. And then I looked at the documentation and I was like, okay, this actually makes sense. So LLMs are really nice because these things I don't think I would have been able to do in the course of a weekend. This would have definitely been like a 1 month project. I would have had this stuff out way past the actual Blossom, and then it wouldn't actually have picked up any like news coverage or anything like that. So if we run that type of analysis, and we sort of, and then I asked it like, hey, can you draw some additional lines so I can actually see where the trees are getting mapped? So there was a bunch of prompting, like go and snap them to the thing, but also show me where those lines are. So again, this is a really nice plot that it would have taken me hours to try to figure out how to do. But now you can actually see like, hey, this point here is going to get mapped to this street because that is the closest street that it's mapped to. And for me, and the way I was thinking about this problem was, you know what, that's good enough. If it's close to 2 streets, I just need you to map it to one of them. Hopefully it sort of evens out that like if this purple street becomes the most popular street to go look at cherry blossoms and it's intersecting with this other street, you're probably in the neighborhood anyway, and you'll just turn a corner if you have to. So it was like acceptable for me that if these things were off by a block or two, you're probably going to see it anyway if it does end up being a place you go to. So this sort of confirmed that this all worked. I then did it across the entire data set. It takes a bunch of time to do. I even tried to confirm it by like drawing this version across all my data set, and then like that code took, like the whole analysis was done and it was still running. So I was like, all right, don't run this code. I believe this toy example was good enough. But what I did end up doing was like look at one block, because I snapped everything to a block, but then the question was like, I eventually need to look at street density. And I didn't know at the time that these streets were already fragmented. So then for me, it was like, Oak Street's really long. You can still go to Oak Street to look at trees, but if just 90% of the street doesn't have trees, like it's not going to show up. So that was a concern that I had. So I did the analysis, I did the data transformation first, which was count the trees on each block and then see what comes from it first, because that was already like, do I have to deal with that problem, or can I just see what comes out of it? So I did a data integrity check after I ran all of that stuff just to make sure that every tree was assigned a street. And then the other thing I wanted to do was, hey, go and like look at Oak, or what did I do? Granville Street. Go look at actual Granville Street and see how things are getting mapped. And this is a little example because the other code was taking way too long to run. So I just filtered it off of Granville Street, and I just looked at Granville Street, and then this is how the segments are broken up. So it's not perfect. These segments, some of them are going more than one block, or maybe this is like an alleyway. I don't really know, but it was good enough in the sense that like at least it was already broken up into individual segments. So I didn't have to deal with this whole Oak Street's really long. What am I going to do if it's actually a really popular place, but it's not showing up? Again, this was a problem that I thought was, I can always fix this later. And this was good enough for the analysis right now. And again, if one block became really popular and some trees got mapped to like just slightly off, again, you're probably going to visit that whole area anyway. And so I was, again, sort of okay with any type of like mapping issue in that sense. The other thing that I was thinking about at this time too was, it would be nice to find like the top 10 locations, but if you were just living in Vancouver, you probably wouldn't care about the top 10. You would just like see where you live and then just visit the places where you lived around you. So the way the street density broke up, it didn't really matter either in that sense, because if you just cared about where you were locally, then this is also kind of good enough. Like if you found one street that lit up, you'll probably be walking around that whole area anyway. So again, I did the whole thing, aggregated it all to the street level. So really similar method of counting density by polygon. You're now counting density by line. And then there is a function that allows you to count the length of a line. So just like there was ST area, there's ST length or something. And then the rest of it really does look like group by, summarize, and is my laptop dying? Group by, summarize, and your normal data transformation steps from there. I have that. we good on time? We're kind of good on time. All right. Okay, so we have the streets. They're all pointed. They're all counted by density. Then really simple task of you have your street summary and you like take the top 20. Or the other thing that I did was like, please make sure to only look at streets where there were more than 5 trees on it because I was deathly afraid, and Claude kind of confirmed it. I was deathly afraid of like a tiny alleyway with 5 trees, and then you're just like looking at a garbage dump of like 5 trees. I don't know how much this actually happened, but it was like one of those, like maybe there should be a minimum threshold. I was also thinking in the context of like photos, and we were all, in my head, it was like before I knew, I was looking for like the row of streets that were all cherry blossoms. That's what I was actually looking for. And I was like, I don't want to spend all this time going to a street and just see 5, right? So that's sort of where that sort of little filter came in. And then again, you're slicing the top 10, 20, whatever number you want to pick. That was completely arbitrary. I ended up doing 30 at one point because it was kind of like fun to look at 30. And then I think I can sort of show you what that all looked like. Okay, so that was the neighborhood analysis. Okay, so this is what it actually looks like when I map all of the tree densities and then do a little filter off of the density of the filter. And so you can see here that like, hey, David Lamb Park lit up. That's a really good confirmation that like this kind of does make sense and why they put the Cherry Blossom Festival there. So again, knowing what I do know about Vancouver Cherry Blossom, this was a good sign that like maybe I can trust the rest of the analysis. Other parts in Stanley Park lit up too, and I didn't know, but like I was like, yes, I know there was somewhere in Stanley Park. So I was also glad to see that Stanley Park lit up. And then Queen Elizabeth Park had somewhere that lit up as well. I didn't know where, but again, it was do these checks where you know that they exist and like hope that you find like a dark green line in that area. So these were all of the streets. And at the time, I did what I did was like I live in Mount Pleasant, and that's when I discovered 7th Avenue as like, oh, there are a bunch of cherry blossoms here. They're not Japanese cherry blossoms. They don't bloom until a month later, but that was like, oh, really cool. I'm going to go to 7th Avenue one of these days. And again, this map on its own, depending on where you live, ends up being a map that is really useful if you're down by Kerrisdale and you're just saying, I don't want to go all the way to these like Instagram heavy tourist locations. Like, what's around the block from where I am? And then this becomes a map that's just useful for something like that. Something that was also kind of really interesting was if you look at this map, you see like a giant hole in Shaughnessy. And like you could make like a socioeconomic like claim that like the people in Shaughnessy don't want like tourists in their neighborhoods, but I'm pretty sure that's just they probably have another type of tree planted there because it's actually a beautiful neighborhood. But it just so happens that there's no streets here that have that are like heavy cherry blossom streets, which was also kind of like maybe there's something else at play there. I don't know, but that's something that's kind of interesting from there. Um, and then what I ended up doing was like count the top 30. So like using slice 30, and then you add what you do is you do a bunch of other stuff of like the street is what I'm looking at. You find a center of the street, and that becomes where the label becomes, and then you put a circle around that center, and then like that's where all these numbers came up. So some of it becomes fairly like manual, like how do I label a figure nicely? But these were the 30 streets, and then this was the data I knew I needed to do the traveling salesman problem, which was I have 30 points. What is the optimal way of walking through these 30 points? From here, this is where I also learned that like, why is this whole area in East Van lit up like crazy? And I also did things like, hey, I want to make sure that you draw like a 500-meter box because if I go to one place, maybe I get to see like walkable areas in here. And so that was really weird that like East Van sort of like what is happening here in East Van? Like QE kind of made sense. Like David Lamb Park made sense. And there was like, oh, we're like there's some areas that you can get to by UBC and like I think this is like, yeah, Sunset and Marple. And you can see like the map. This is where the geometry data becomes really useful because when I'm hovering over a box, it's giving me the neighborhood. But here was really interesting. And this was also where I discovered it's it's common knowledge if you lived around here. But Rupert Street is like a really popular street for cherry blossoms. And then I spoke to our stats department, one of the admins there who live in East Van, and he said, like, yes, that is absolutely one of the best places to look at cherry blossoms. It also is the place to look at cherry blossoms too, because Rupert Street goes, the way the street is angled down means that you have a complete sight line to the North Shore Mountains. So it is the place for cherry blossom to mountain in the city. And again, you're kind of using local knowledge in that sense. Just as like another aside, there is this idea of view cones in Vancouver, and there is a view cones data set. So you could actually optimize viewing locations if you're like a photographer. And again, that's all in the Vancouver Open Data Portal. So if you're trying to optimize not just street density, but you're trying to optimize street to mountain view, that is something that you can add as well. And again, these are all different GIS layers that you can put on. What am I doing? How are we doing on time? We're kind of doing okay on time. Okay, so I have 30 points, or in this case, I looked at the top 10 points. And this was sort of the thing that I was trying to do, which was how do I optimally map this? And this was using Kyle Walker's algorithm. The example he used was for like UPS shipping, like the best way to do shipping routes across highways. I thought it would be the same. I would get the same results. Clearly not. And then this is where you see like potentially holes being in this data set becomes a problem because it clearly doesn't know how to draw a straight line from here to there. So that's when I sort of like, oh, that was really sad. How do I like deal with this problem? And then Claude kind of helped me find like other ways to like deal with this problem. But one of the things I could do, which I ended up doing was, okay, let's not actually use the street information and just given these 10 points is draw me straight line optimal paths. And so what that looks like is something like this. So it started in David Lamb Park, probably because it was number one. But you'll notice that number two is in Stanley Park, but it's actually saying like, hey, you should navigate these two locations first. So the optimal traveling path, I would argue, probably start from Stanley Park and then come down to David Lamb and then make this little circle down here. But I was okay with this set of results because you might as well start from where the Cherry Blossom Festival is and then toward the city. And this was before I realized the whole microclimate different bloom times issue, but this was like my way of moving through the city. And so again, this was like the first initial plot of like, you know what, this is good enough. This is what I'm going to tell the world. Hey, if you want to see all the cherry blossoms in the city, here's the 10 places to go. It kind of makes sense. It hits David Lamb Park, Stanley Park, is this QE? I think that's QE. Yeah. And then somewhere like towards the west and then the east. So you kind of like see all of Vancouver. And I was like, great, that's great. That's all I need to do. My analysis is done. Yes, finding top 10 streets. Yeah. So the package I was using, this came from Kyle Walker, was this spopt. I don't know how he plans on pronouncing this. But this is sort of what the traveling salesman problem is, which is given all of these points, how do you move through them? How do you make sure you go through all of them with the minimum amount of like backtracking? It's a very hard problem because the more points you have, there are more like the number of paths for you to calculate explode. So it is like a very computationally intensive problem. And there are different ways that people have dealt with this problem. But that's what this package was doing. There's a vignette and it's a very nice vignette. I thought I can get those same results. I didn't, but that's where this all came from. So I'm going to skip all of this. But after the failure of that, Claude, I was pretty much saying like, hey, these results are crap. How do I actually do traveling salesman not using this package? And Claude suggested this little pack or this service called OSRM. And what this ended up doing, wait, was that what this was doing? Yeah. What this ended up doing was, hey, I have all of these points as GPS coordinates, like just route them for me. And there's different routing profiles like foot or bike. And so now I was thinking, oh, I kind of run, like given these points, like it can start to generate run and bike routes for me. And so again, this was something I didn't know I could do. Clearly, it's hitting an API endpoint, but Claude sort of like wrote that portion for me. But it really worked because all of that analysis and the points and the data was already there. And now it was just me asking the next follow-up question in this analysis. And then the other thing that I learned, and this again was from Claude as well, was, hey, given those map routes or the path from OSRM, you can actually do a GPX export. And I cared about a GPX export because that's what you can load into Garmin or Strava and then like put it on like your phone, and then you can actually go and follow that route. Because then now it became like, how many top locations do I need to get to like a 10K or a half marathon, a marathon, or like something more if you're biking and stuff like that. And so that's where that sort of process now became like, okay, the analysis is kind of all there. Now we're having fun with it in terms of like what we can do. So you can do a GPX export of that as well. And then so that's where I sort of was like, okay, we can actually have like a marathon route like coming up. Top 10 gets you a little bit over half marathon. If you connect all the lines straight, but it gives you 35K if you kind of like do it as a route. So it was like 35K is close to 42. You can probably put in some like bathroom water break somewhere and you'll get really close to a full marathon. And so that's kind of what that ended up doing. And then I ended up like, okay, let's get to, so I do ultra running. So then the thing was like, what would it take to get to 50K as a bare minimum? And then don't say that I'm going to run it, just say that's what cyclists are going to do. So then that's why like those numbers were picked. It was just like me trying to do cutoffs until I got to a number that was like, I'm willing to maybe do this on my feet one day. So the other thing that was really cool, and again, this came from the help of Claude, was oh, I need to go to the actual blog post for this. Was in the process of mapping out the routes, when I was trying to tell it like, hey, give me an optimal path for all of this, Claude actually did suggest to use Google Maps. And what it ended up doing was it put all of those coordinates into the normal API of Google Maps. And then you just have Google Maps do the routing for you. Google Maps does do this. You just like question mark location and it can do that. It only maxes out at 10 at a time. So I can only do the top 10 here. So the top 30 was like 3 sets of 10. But this was really interesting. One, I didn't know it can do this. But if you're thinking in the lines of like science communication, this is the most like accessible way to get it to any person, right? Everyone knows what Google Maps is. They can look at this map. You can reorder points if that's not how you want to move through these points. So it also becomes a pretty good user interface. You can map it by car so people can actually drive to these locations and not walk and bike. You can potentially do it by public transit as well. So this is one of those like, hey, this is how you get something that is just the little analysis that I'm doing for fun to making it really useful for people outside of tech. And so again, I didn't know that. I know that now. Hopefully now you know that. The limit is 10, and it really is like a fancy URL. That's all it did. I realized that's all ChatGPT did was like take a string and then just string concatenate this monstrosity. And I was like, originally when I saw it, I was like, this hallucinated like a thing. Like I'm gonna click this link and my computer is gonna die. And then it turned out that it was just a Google Maps link. So that's kind of what happened there. Okay, so that's pretty much the entire analysis. So what I ended up doing was I'd finished that analysis, I believe, like in the middle of the night Sunday, and then I couldn't sleep. And then so Monday morning, I just ran it. I ran part of it. The part that I ran, so this was the top 30 route, but I took like the right-hand side and I just did my own like manual mapping. I left out downtown because I knew David Land Park was like a thing. So I ran straight down to QE and then did a big loop around East Van just to confirm all of this stuff. Uh, and then what I realized was, yeah, it worked. So on the left-hand side that's what it looked like in QE. And then on the right-hand side is what it looked like on Rupert Street. And I was like, oh, that's so sad because I was looking forward to this whole giant street on Rupert Street instead of all these like bare trees. Especially when I went through QE first and it was like in full bloom. I had high hopes and then completely disappointed towards the end of that run. And then it was like a very sad run from East Van back home to Mount Pleasant. So this was March 30th. And then March 18th, I sort of went back to Rupert Street and like, here's a picture of a cherry blossom. Those are the lions right there. And that's like one of the view cones that you can kind of see in that sort of area. So one thing that if I were to make this, and I probably will, use this as like a photography resource is like put in view cones as part of like some sub-analysis. And then you could, in theory, have like help all of the photographers in the city find their places. Or I just blew up like everyone's favorite spot. And like I didn't mean to do that. But yeah, so like it was really cool to like do this whole analysis and then literally run it to like prove to myself like really see that like this was a real thing. So that was kind of fun. So yeah, open data, really important feature of how this all worked. We snapped all the trees, we looked at the density, and then sort of created interactive maps. What's also really nice as well is like on the reason why I was looking into like Map Libre or all of these things was this is a map that's interactive. It's on a Quarter website, completely hosted on GitHub Pages. So like there's nothing that I've paid for. The map isn't running on a server. It is like completely embedded in this site. So I wasn't expecting like actual news coverage, but it was one of those things where I didn't have to have an additional service running to have these maps exist, especially if I wanted something interactive like this, because again, I wouldn't have actually known this street was called Rupert Street until I zoomed in enough, right? So that was some of the like original like find something that's interactive because you want to be able to zoom into it, but then also find something that can get pumped into the browser completely so I don't have to worry about another service, which is why this is not like a shiny app because then I need to have a server running in the background. Yeah, and then we fed all those points through Traveling Salesman, and then that didn't work out as well. So then I just fed it all through, got it as a GPX file, fed it into Strava, and then like manually just moved points around until I was comfortable enough running that distance and stuff like that. So not perfect, which kind of makes sense. The Traveling Salesman is trying to find optimal paths. So even if that did work out, just because it's said to go down that street probably doesn't mean you should be going down that street, especially if you're biking. So, there are definitely optimizations that should not be automated in that sense. Again, the thing that sort of made this work that I didn't know was this whole ST nearest feature. That was like my big function learning of this whole analysis. And then using all the existing spatial functions to sort of do those calculations for you. So yeah, find density, look at density, not raw counts. That's something to standardize is always really important when you're doing data analysis. There's this whole other thing that like I don't fully understand around the traveling salesman, around like calculating the cost matrix, which is, yes, trying to find optimal paths. But at a certain point, it was like I was just trying to get Claude to get code working. And then thank God it got something working, but then it just ended up being like this didn't work anyway. But it did help me find like other solutions that probably if with enough Googling, you probably would have found it, but it definitely would not have been like found it in 10 minutes. It would have been like found within an hour at best kind of solution. So yeah, Claude helped it a lot, especially the making the maps pretty. Like I got points on a map and I was like, I don't know, this is the ability I have. I didn't know about the Google Map URLs. I didn't know about the OSRM fallback. After all the code was written, I was like, go and comment my code. So like as a public resource later on, it will be useful. So that's why the code comments look very structured. I did not write that. I did proof it, but I didn't write it. Also, it helped a lot with setting up this particular talk because the code was all there. I already had the blog post. I kind of had an outline already with like how I wanted to structure this talk. And then I was like, can you take all of this information that I already have and just at least do a first pass, like fill in my slides for me? So that's what it did. And that was kind of really nice. And then what's also nice was like some of the like ASCII like arrow diagrams of the flow. It was like it made it for me. In the past, it made it for me right away. In the past, I would have like tried to make my own mermaid diagram out of it, or I would have taught Claude to make the mermaid diagram out of it. But it kind of just did it, and I was like, this looks good enough. It's fine. I can just say that Claude did it, and that's like my shout out to Claude. Again, which is all to say that these LLM tools are very useful. Like it really did take like a project that probably would have taken a week or a month and like became a like ADHD hyperfixated like weekend project. Just because that iteration cycle became really, really fast. And I think like the total cost of the initial pass of the code was, I think it was like $4 or $5 worth of token count. 10 if you want to round up like a lot. So it really wasn't that much. But at the same time, I wasn't like, I was prompting the direction I wanted to go because I don't think it would have thought about all of those problems or it probably would have done something weird, to be honest, on how it would have calculated the problem that I was trying to work with. Open data is amazing. This would not have been possible. I don't know who funds or how the open data portal gets funded, but it's amazing. It's a resource that exists because I got immediate questions about, can you do the same thing for blank neighborhood or blank city? Like someone on Reddit was like, can you do it for like this city in California? And I looked, it's like, you don't have an open data portal. Like you don't have tree data. Like I'm not collecting tree data for you. Same even in Vancouver. I went to look at West Van, North Van, Burnaby, Surrey, and Richmond, and they don't have tree data. Or it wasn't very obvious that they had tree data. The open data portal on their websites also don't give me the impression that they have any data other than there's maybe a website. So this is really something that is really kind of cool that Vancouver is doing this, that has this. Say again? Yeah, the city. I mean, it is like an official government thing. Yeah, like whoever is funding this, like whoever is in charge of this in the city, like, yeah, you can have more of my tax dollars. The other thing is my friend who does GIS work for the city, which she'll be giving a talk to the MDS students. She's using the tree data for city planning because she's using it to plan when and what streets need to get cleaned up when the leaves fall in the fall. So they're doing fall planning for street cleanup like now, and like she's using the tree data for stuff like that. So there is like this combination of something like this becomes useful for the city, but then it becomes useful for like these random projects like this. And then just to wrap this kind of all up with our last talk that Grace gave, again, this whole entire stack is just a Quarto website, or you're looking at a Quarto presentation. It is hosted on GitHub Pages as well. I'm just running this locally, but that entire stack is a free tool stack that you can do. And again, if you're thinking about communicating results, all of this stuff wouldn't mean anything if I couldn't present it to someone. Or in the case of like Reddit and the news agencies, this wouldn't have meant anything if I couldn't give them a link. And if I couldn't give them a link with, and the other thing is I essentially did their work for them. Like if you look at this whole analysis, like all they needed to do is like take screenshots of what I presented. So then it became this thought process of like, outside of like data science details, like I don't really talk about density counts that much, but I'm presenting like, here's the streets you should go to. And that's the results. That's why I'm calculating density. So if you think about it in like how you want other people to interact with your information, like simplify it for them, like what's the most important thing. I even wrote like looking at the street data, like, hey, here's an optimal 1 day walking path, which goes from Stanley Park down to Davie Street's also a big street in Vancouver. So it goes from Stanley Park to Davie Street to David Lamb to like Granville Island. And I was like, hey, if you only have a day to look at cherry blossoms, here's like a route that you can do, right? Like at this point, this was an addendum when I realized like some news agency might pick this up. Like so no one's going to want to run like a marathon just to see cherry blossoms, right? They only have a day in Vancouver. So then that again becomes like a communication problem of like no one's going to do what I just presented as like a reasonable thing. So like what is a reasonable thing? Well, this seems like a reasonable walk for people to do across the entire day. So a lot of iteration happened in this initial blog post, but this initial blog post then was there just for general audiences. And what I'm presenting today, which will be the part 2 blog post, is like for the technical audience, right? So there is a difference between like who you're talking to, using all of these tools, right? Like the news agency doesn't care I'm using Cordo. They just care that like they can take screenshots without constantly asking me about like, can you shift this to the right or like something like that. So that's sort of why the interactivity also helped a lot too. And then again, appreciate the city planners. This was on one of my runs, and this was a cherry blossom in full bloom behind Kensington Park sign, which was the only cherry blossom in like that whole area. But I remember running past it. It wasn't even like I was running on past it on purpose, but it was like just to show. I mean, when I saw this, it really became like someone planned for that tree to be there behind that sign for like this moment of the year, right? So, if anything, this whole thing has also made me appreciate like not only the person who like maintains this website, but like whoever decides to plant what tree where, is also like I don't know who they are, but it was really cool to see all of those bits and pieces happen. Next thing, I have a whole year before this all happens again. Like I said, different bloom times is a problem. So everyone's taking their photos. The goal is to slowly cross-reference the photos that were taken by the date and just get a relative time for areas. And then I have the tree species. I suspect it's less microclimates, and I suspect it's more tree species. And so the idea would then be, can you do top 10, 20, whatever routes, but on a particular week, right? Because you don't want my problem of like going to QE and then all of a sudden it's like, what is happening? Which also means that it doesn't seem like you could run across the entire city and then see the entire city in bloom. But it would be cool next year to actually plan a marathon route where the route is actually in bloom. So that would be like a goal for next year, which is plenty of time to make that happen. And this is all the analysis. That's all the code. And I think that's my last slide. Here we go.
Do you have any questions for Daniel?
Any questions?
Put them in the chat. Thank you, Daniel, for
Yeah.
presenting and running
And running
on the computer and in person.
Yeah.
So, important. I think.
Yeah.
Did you take your mom to UBC at all? Because the gaping hole in this data is because UBC is not.
Yeah. UBC was gone by the time she came in mid-April. Yeah.
But Open Data has the UBC data for at least UBC.
Do they?
No.
No. Well, so this is Vancouver Open Data. Technically, UBC is not Vancouver. It is under University Endowment Lands, which is a totally separate like government agency. So I would not agency, like government district, like region. So that's why when you look at Vancouver data, you might get UBC like in it. But if it stops at Pacific Spirit Park, that's why it's not UBC. It's not Vancouver. But yeah, this was like the most funny and like sad, like what the hell? Because at that point I'm like 15K in, like I have to run back home, and so you're kind of just like, well, damn.
climate change.
Yeah.
They probably might have a better idea of like how to best like estimate that, because when I used to work for the museum, people used like the collection data to kind of understand how flowering times have shifted over the years. So
Yeah,
potentially that is.
Yeah, like I could do some, even like you can even do something historical with like just go back and look at photos and like track it by week. When I first saw this, I was like, oh man, I'm gonna have to get climate data and I'm gonna do this whole climate analysis. But then, I mean, this is also where like my limitation is. The only place I know to look for climate data is like any like national climate service. And like and I know you don't have weather stations on every block. So like even if I got climate data at that level, there is not enough granularity to tell the difference between East Van and like East Van and like UBC. Like the weather is all the same, right?
Looking for like a web scraping data from like, because I know the UBC Botanical Garden has like I just looked it up, they have a forum where people post stuff, so potentially we'll need to scrape.
Yeah, I mean, part of me is like, do I need to scrape the data? Because technically that might be illegal. Well, even cloud scraping is technically it might be illegal. Like the first thought that I have was like, I don't need that much information to get rough things. I think it's this. Yeah, so like the official Vancouver Cherry Blossom Festival, they have people take photos. I don't know if anyone's seen this, but like here's like, well, that photo's not showing up. There's like a photo with like, and I was like, is there a date? And I was like, there is a date. And like, that's all I needed. Right. And then like, I can maybe cross-reference this to the map that I have to figure out like species. And like, my guess is I only need like, I can hand make like 50 points. And that's more than enough to like, at least prevent me from running down a street that's empty. Like, that's really the first pass is like don't run down a street that's like not blooming. So that like even if I were to route like a whole marathon worth, like as long as most of the streets are